coding. So the first one we have given is 10, 10, 10. And we know that this is class A. If you go from class notations, because we have not given anything. So the subnet mask is default, we say. The reason for saying default, because this could be changed, right? Now we know. In subnet mask, we are referring the bits allocated for network as ones. So we have 1, 1, 1, 1, and 1, 1, 1, 1. So this is for the network, and the remainings are for the host bits. So this is what we have discussed last time. That is, so similarly, if you look at the second one, we know that this is class B, then subnet mask. This is also default subnet mask. I'm going to say subnet mask, right? Will be the first 16 bits 1. So because this is the allocated for network. Then remaining 8 bits for the hosts. So the last one comes as, right, class C. So in class C, we know the subnet mask is, because this time you are allocating 24 bits for the network, right? The default mask is then 24 bits. And the remaining 8 bits, right, for the host. Okay, now that we have discussed, let's move on. Let's discuss how can we create subnets within class A network, right? So I'm going to use class A. Class A subnets. The idea is I'm going to create subnets within class A. Right. Okay. So in class A, one thing we need to discuss. The first thing is we are using first 8 bits. We call first octet, right? In class A, the first octet. Now octet means 8 bits. Is used as network identifier. We know that already. And the rest. Now rest means we have 24 bits. So these 24 bits we use for hosts. That means the computers in the network. So specifically, this is around like 16 million. We discussed the value. 16,777,214, right? That means 2 to the power 24 minus 2. So this means 2 to the power 24 minus 2, right? So let's write down. So this is what we are going to discuss under subnet host. Now the idea is clear. If you want to create subnet, if you want to divide the network within class A, you have to borrow bits from host. And this will change the subnet mask because we know already, right? When you're borrowing, right, network part is going to change. So let's see what will happen. So what we need to know is to make more subnets in class A, because this is class A networks we are going to discuss. We need to borrow right bits from class A, and this will change the subnet mask. So what was the subnet mask? We know in class A we have, right, 8 bits, and all the others are 0. Right, now let's see what will happen, right? We see, depend on how many bits we are going to borrow, we are going to see what will happen, right? So I'm going to create a small table, and within the table, right, we can look at so the first part I'm going to look at is network bits. So I'm going to create text. I'm going to have first network bits because this is what we are going to change, right? And we know we start network bits with 8, right? So that is a starting value. And the next one, host bits. You can put it as a, so initially we start with 24 bits. That part is also okay. Then the subnet mask. We know initially it's 255,000. That is also clear, right? These are, we already know these things. Subnet mask is 255,000. We haven't borrowed any bits. So this is the initial state. Bits borrowed. We have not yet borrowed anything. So therefore, right, the number of subnets, if you talk about, that means the networks, is 1, isn't it? Because we haven't borrowed any. So we can say 2 to the power 0. We haven't borrowed because number of subnets depend on number of bits we borrow. Right? So we haven't borrowed any. So therefore, we have a single network. Right? Then we can say how many hosts in a net subnet. Right? So we can say that, okay, number of hosts per subnet. So the right now it's 16 million, right? Because this is the default one. So we got this, how we got this? We know that this is 2 to the power 24 and we subtract 2. So this many subnets we already have. This is how we are going to start. Now let me check what will happen now. Now this is what is going to happen. Right? Now, let's say we want to divide into 2. We borrow 1 bit. We borrow 1 bit from host to network. So now this is going to be changed, right? So this is going to be 9 because we are going to borrow 1. When we borrow 1, host bit is going to change to 23. Now, whenever we borrow 1, now we have subnet. Earlier we have 8 bits, now it becomes 9 bits. Kanta, can you tell me, if you have 9 bits, what is the subnet mask keys?
256000.
No, it's not 256. The 8 bits is 255. That one goes to the next one. So the next part will be 10000000. To explain that, let me type it separately. So this is what we have in the beginning, right? So this is what we have in the beginning. Right? So in the beginning, we have this. So when you have like this, the subnet mask is 255000. Now what has happened? We are getting 1 from host bit to here and make it a network bit. So this becomes 1. My question was, now what is the subnet mask? We are getting the first 8 bits, no? First 8 bits, no change, 255. What this number represent now?
128.
It should be 128. So now this becomes 128.0.0. Exactly. So now my new subnet will become 255.128.0.0. So how many bits we have borrowed?
1 bit.
1 bit. Now, how many subnets we are going to create now?
2 subnets.
Yeah, we are dividing it into two subnets. So how do you know how many subnets? It's since we have borrowed 1 bit, 2 to the power 1, it's 2. Now that we have borrowed the 1 bit, right? Since we have two subnets, when you're dividing by 2, this becomes one subnet, we will have about 8 million hosts, right? So if you divide in this, so this becomes now something like this. You don't have to remember these numbers, but for the completeness, I will put it. So actually, to get the actual value, you have to get now, since you have remaining is 23 bits, you get 2 to the power 23 and subtract 2, and you should be getting this. So when you borrow another bit from the network bit, this becomes 10 bits. Since we have borrowed, host bit reduced to 22 bits. Now, when we have like 22, so 10 bits, right? Then we have 255, right? Then the next 8 bit is 11000000. So that is 120 plus 64. That is 192, 0, 0. So the number of bits borrowed is 2. So that means now this time you are creating 4 subnets because you have 2 bits. So 2 to the power 2 will get 4 subnets. So the number of computers now will be half of this, right? So that means you will get about 4 million, right? So you don't have to calculate this one, 4, 19, 4302. Simply you can get this by getting how many bits allocated. It's now 22, subtract 2. And this many hosts are inside. Okay, right. Now let's continue this. I'm not going to discuss the remaining, right? So if you go like this, right? At some point, the number will increase. Let's say now you are getting, you are going to borrow, let's say 21 bits, right? So that means the number of host bits will be reduced to the remaining, right? To 3. Yes, can you fill the rest? So let's say this is 30. And let's say this is 2. Yeah. Can you fill the last 2 rows? Now, when you borrow 3 bits, sorry, when you borrow like, in this particular case, you have to borrow a lot, right? 21 bits. So that means, except for the last 3 bits, all the others are 1. So that means we have 255, 255, 255. Then we have all ones except last 3 bits, right? So it should be 248, isn't it? Yes. So now if you take number of bits borrowed, so we can come here. So the number of bits borrowed are, it's 21 bits. So we have borrowed 21 bits. So the subnets then, since you have borrowed 21, right? So that will be around like 2 million, isn't it? 2 to the power 21. So what is the value of 2 to the power 21? So let me use a calculator. Yes. Two to the power 21 will be around like 2 million. 2,097,152. 2 million, right? 97,152. So these many subnets are possible, right? The number of computers in will be small, right? Because then definitely we have 2 to the power 3 minus 2. So you will have only 6 hosts. 2 to the power 3 minus 2. Only this. And then, sorry. And then when you have borrowed 22 bits, right? So the subnet mask will be 255, 255, 255, right? This become 252. So which means number of bits borrowed become 22. So when you have 22 bits borrowed, right? So we know that it's 2 to the power 22. So when you take 2 to the power 22, 2 to the power 22. So now this becomes 4 million. So the number of subnets, number of networks that we can create will be 4,194,304. And now, number of hosts, the computers within the network will be very small. It just becomes 2 to the power minus 2, that becomes 2, right? This is the smallest number of computers you can have a network. At least you have to have 2 computers, right? To have it. Okay. So few things that we need to note here, right? Make a note of this because this will be helpful for when you're answering questions. So the first one is number of subnets. Number of subnets. The idea of subnet is number of networks we are going to create. So this we can calculate by getting the 2 to the power number of bits borrowed. Right? So make a note of this. So the number of subnets are equal to number of 2 to the power number of bits borrowed. That is first one. The second one, number of hosts. That means number of computers in the number of computers or devices in the network will be 2 to the power number of host bits and minus 2. So make a note of this. Right. The next one we are going to discuss class B subnets. Now we know the idea of subnets. So given IP address, now we should be able to make subnets, right? So let's look at what are the things we need to first remember about the class B. So in class B, we know that we are using 14 bits. Why we say 14 bits? Because the first 2 bits are fixed, right? So because of that, we can say 14 bits are used as network bits. Altogether, it's 16, right? But we know that how much we can create. And then the number of host bits we know, right? Uh, we can have 16 bits for host bits. Right? Now we are going to create subnets. So we can say to make subnets class B, we are going to borrow bits from the host. Right? So to make more subnets in class B, now we are going to borrow them. Right? So let's create the same table as earlier. So in this time, so let's put down network bits first. So initially we have 16 bits allocated for the network. Then we have host bits, same number, again 16. So we have host is also 16 bits. The next subnet mask default, and we know that subnet mask is basically we will have ones represent the number of network bits as well as host will be 0. So since we have 16 bits, we have 255, 255, we have 0, 0. So this is the default subnet mask, right? And the next one, we have bits borrowed, right? Number of bits borrowed, we know. Now in this particular case, right? Initially, it will be 0. And then the number of subnets and number of networks, initially it will be 1 because we have not borrowed any. Simply it is 2 to the power 0. Right? So the number of subnets are 2 to the power 0. Then number of hosts per subnet. Initially, you have 2 to the power 16. That means 65,536 minus 2, you have 65,534. Simply the number is 2 to the power 16 minus 2. Right. And we are going to borrow 1 bit from the host bit. Right? Let's say you are going to divide into, you are going to create 2 subnets, you borrow 1 bit from the host bit. So now network bits become 70 and host bits reduced to 50. right? Now the subnet mask will be changed because now this becomes 255, 255. So one bit becomes a network bit, that means 1, and all the others are 0. So this becomes 128 then, dot 0. And we know the number of bits borrowed is 1. So which creates two subnets. Why 2? Because you are borrowing 1 bit. So 2 to the power 1. And that will reduce the number of hosts that you can create. Now, earlier you have about like 65,000 uh, uh, hosts in a network, computers in a network. Now it becomes a half of this. So that is around like 32,766. So the reason is we will have 2 to the power 15, right? Subtract minus 2. So this many hosts are possible within the network. Right. Can you calculate the last one then? So if you go along like this, the maximum number of bits you can borrow will be 14 because the number of hosts you can have, the minimum number will be 2. So when you borrow like 14 bits, this becomes 30. Right? Can you feel that line? So we know that to create class C network, we have to more subnets class C bits from the host part are borrowed, right? So that we already know, and you have worked on this one. So if you summarize what we did, so we start with network bits, and we will have 24 bits in the beginning. So that's the starting value. Then we will also have host bits, the remaining. So that will be 8 bits. So we have 8 host bits. And then we have a subnet mask. Initially, we have 24, that is 255, 255, 255 at 0. So that will be our subnet mask. And number of bits borrowed in the beginning will be 0. So that you already know. And then subnet mask will be initially 1. So we will have 1 because we have to the power 0, we have not borrowed any. So that is the starting value. And finally, host per subnets. Now, this is the smallest one possible because we know that the number of hosts per subnet is very minimal because we have 8 bits. So 2 to the power 8 is 256, but when you subtract 2, that means 2 to the power 8 subtract 2, we'll get 25. Right? So this is what you need to remember about this one. So the borrowings are easy. So the initially when you borrow 1, this becomes 25. The host becomes then 7, and the network mask becomes 255. Sorry. So this becomes 255, 255, 255, and it becomes 128. And the number of bit borrows will be 1. And the subnet mask will be, it will divide into 2, right? So this is 2 to the power 1. And the number of subnets, hosts per subnet becomes 126 because it's 2 to the power now 7 minus 2, right? So if you go along that way, the minimum number you can have is, so the maximum number of bits you can have is 30. The reason is because the minimum number of hosts that possible, the host bits, then this becomes 2, right? You cannot go, beyond this point. So when you have this, our subnet mask become 255, 255, 255, and 252, 252, right? And the number of bit borrowed, now it becomes, right, the 6. So if you have 6, we know, right? When you have 6, we know how many subnets are possible. So we have 2 to the power 6, that is 64. 2 to the power 6 is 64. And number of hosts per subnet becomes 2. That means 2 to the power 2, 4 minus 2 is 2. So this is 2 to the power 2 minus 2. Right. Okay, so your answer is correct, and that's good. Now, yeah. So the decimal values we should, know, and when you're given this, we get identify the classes, the number of ports, right? So I will give you IP addresses and subnet mask, and you are supposed to identify uh, the network class, number of subnets, and number of hosts. So let's do exercise since we have already done this, right? So exercise, let's write down this exercise. For the following IP addresses and subnet masks, right? Identify the network class, number of subnets, and number of hosts. So here are the IP addresses and subnet mask. So the first one, IP address 172.16.2.1, and the subnet is given 255, 255, 254.0, right? Right. Now, given this IP address, the first thing that you can notice is it's start with 172. When we look at the ranges that we have actually discussed the summary, 172 belongs to class B, right? So the network class, so we can say it's B. Now, when we say network class B, we know the default uh, subnet mask, you have 16 and 16. So now what we have given here is 254, right? So when you are given 254, you can see how many bits you have used, right? So the number of subnets we want to look at in this particular case, how many bits borrowed in this particular case, right? So the default is in network, default subnet is mask is 255.255.0.0. But the given subnet is 255.255.254.0, which means if you closely look at, we have how many ones? So this is 255. Now 254 means we have, right, 7 bits borrowed, right? So from this we can identify number of bits borrowed is 7 bits. Now when you know number of bits borrowed, now you can identify number of subnets. So we can say number of subnets is based on the number of bits borrowed. Subnets is, we know that it should be 2 to the power 7, right? So that means we have to have 128. So the answer is we have to have 128 subnets, which means 128 networks we are going to create. Now, the next one is number of computers on each. So the number of hosts per subnet, right? To see how many hosts per subnet is, then we look at the remaining bits for the host bits. It's 2 to the power 9. So we can have 2 to the power 9 minus 2, right? So that becomes, right, 510. Good, your answer is correct. So let me give you a, a, a right. Now you are given another question. So let me check the answer for this one. So in this one, you have given couple of subnets, right? And then a network with 5 subnets, each with at least 16 hosts. Identify a suitable subnet mask for the following, from the following. So this time you have given only the subnet mask. So from the subnet mask, you can identify, right, how many bits you have. Right? You can identify network bits and number of host bits. When you know the network bits and number of host bits, you know how to calculate number of subnets and the hosts. So looking at this one, identify what is the suitable mask, right, from the following list. So another way to represent IP addresses is, instead of class space, we can talk about classless interdomain routing, or CDIR. The point here is when you have class A, class B, class C, and so on, they are limited. So for example, in class C, we can have 254 hosts, but if you need more, you have to go for class B. But in class B, it allows for around 65,000 hosts, which is wastes. So because of that, there's another way we can represent IP addresses, which we call classless inter-domain routing. In this particular case, together with the IP address and with the number, with a slash, will indicate how many bits allocated for the network. So in this particular example, when I say 192.0.0.0/24, that 24 represent network bits. So we can talk about two ways of network addressing. So we can provide IP address and subnet mask. For example, for the previous one, we can say 192.0.0.0 and subnet is 255.255.255.0. So same one, if you're using CIDR, we can represent it as 192.0.0.0/24. So let's do a small exercise. Given that 172.16.2.1 and subnet mask 255.255.255.0, okay, let's find what CIDR is.